So in our previous video, we were looking at total costs, total variable cost, total fixed cost, and total cost, which is the variable plus the fixed. And what we said is that when we look at the cost, we really care about when we're deciding how much to produce is the per unit costs. So we want to look at now is average cost, average variable cost, average fixed cost, and then look at marginal cost. That's the extra cost to make one more unit. These are the key costs when we look at how much we're going to be willing and able to produce. And the reason we go through the other discussions about productivity is that we're going to soon learn that these productivity measures will impact these per unit costs. And the total costs that we talked about before, we're simply dividing those by the amount produced to get these per unit costs. So let's look at the per unit cost, and let's start with average fixed cost. All right, so average fixed cost is going to take the total fixed cost and divide by the amount we produce. So if we go back to our table here, we're going to take total fixed cost divided by the amount we produce. So our total fixed cost was the $10 stapler, and we divide it by our output. If we divide by 0, anytime you divide by 0, it's undefined, so we'll skip that one. But here we have a $10 stapler and we're producing 6 units. So if we take that $10 stapler and we divide it across the 6 units, then $1.67 of that stapler has to go into every widget that we're going to sell. If we have an output of 7, we still have the $10 stapler. We now get to divide that cost across 7 units. So what we find is that we need to put $1.42 of the stapler into each widget we sell. Oh, 43. When we produce 11 units, we still have that $10 stapler, so we're taking $10 and dividing it across 11 units, and we get 0.91. And let's do the last two. So again, $10 stapler, but now across 13 units. 10 divided by 13 is 0.77. And lastly, we have a $10 stapler, spreading it across 15 units, and we get 0.67. So notice what happens to our per unit fixed cost. The more we produce, the more we can take the stapler, which is fixed at $10, and spread it across more and more units. So this might encourage us to produce a larger quantity, especially if we have a big fixed cost. So companies that have big fixed costs tend to produce much larger quantities because they need to spread that cost out. This would be companies that have large infrastructure. So if we think about like Dow or Nova, they have this big chemical plant. That's a lot of fixed cost to build that infrastructure. So they produce lots and lots of polyethylene, polypropylene plastic pellets. If you're a company that provides like cell phone service, right, you have to put up all the towers and you need more customers using more of the data in order to spread out that cost. So anytime we have these big infrastructure or expensive machines, the more we produce, the more we can spread that out. So let's graph that. What does that look like? Well, we're going to create a graph here, and this graph is going to have our average fixed cost, average variable cost, and marginal cost. All those average costs and the marginal cost on there. Let's just see in terms of a scale. 1, 2, 3, 4. I want the top here to be 6, so I'm just trying to figure out how to divvy this up. What do we have here? 1, 2, 3, 4. 1, 2, 3, 4, 5. 2, 3, 4. Okay, so let's make this 3, and I'm just gonna 1, 2, 4, 5. All right, we'll see in a moment why we need it to be 6. Okay, so quantity of output. Again, we are going to be plotting not the number of labor like we did with productivity, but we're going to be plotting the number of units or total product that we produce. So 2, 4, 6, 8, 10, 12, 14, 16. And when we look at our output, we had a 0, we had a 6, we had a 7, we had 11, and a 13, and a 15. Okay, so we are plotting total fixed cost. We are skipping the 0, average fixed cost. We're skipping the 0 and we are starting at 1.67 when we have 6 units. So at 6 units, we're at 1.67. At 7 units, we are 1.43. At, what is this? At 11 units, we're 0.91. And at, what do we have here? At 13 units, we're 0.77. And then we are 0.67. So notice this average fixed cost is continually declining. As we said, the more you produce, the more you can spread out that fixed cost. So our average fixed cost curve should always be continually declining. And you'll notice that it gets smaller and smaller and smaller. The average fixed cost will never cross this axis here. The average fixed cost will never get below 0. In fact, it'll never actually get to 0. It'll just get a smaller and smaller and smaller fraction. And that's because we're just making bigger and bigger and bigger numbers, and we're constantly dividing them by 10. So if you were doing 5,000 divided by 10, 10 million divided by 10, you're still just getting smaller and smaller fractions. So what we call this graph is we call it asymptotic. Asymptotic means that it's going to continually decrease, but it's never going to get to 0 across that axis. Okay, so we see this shaped the average fixed cost curve. All right, let's look at the other per unit costs. So the next one we want to look at is average variable cost. Average variable cost takes the total variable cost and divides it by the amount you produce. So let's go and take our total variable cost divided by our total product. So here our total variable cost is 0. When we produce 0 and we divide by 0, it's undefined, so we skip that one. All right, we produce 6 units. Our total variable cost is 5, so we're doing 5 divided by 6, which is 0.83. Then our total product is 7. We have 2 workers, so the cost is 10, so we're taking 10 divided by 7. And we get 1.43. All right, so then we're producing 11 units. The total variable cost is 15, so 15 divided by 11. 15 divided by 11 is 1.36. Then we have our total variable cost of 20. And we're producing 13 units. So 20 divided by 13, 1.53. Wait, 1.54. Okay, and lastly, we have our total variable cost of 25 divided by our total product of 15. So 25 divided by 15. Oops, try that again. 25 divided by 15. All right, 25 divided by 15, 1.67. Okay, so let's look at what's happening here. Our average variable cost in this situation goes up, and then it goes down, and then it went up and up. Okay, so let's graph that, and then we'll figure out what's happening. So at 6, we are at 0.83. And then we are at 1.43. And how does that compare? That's the same number, so we should be here. Okay, and then at 1.36, and that's at 11, we're at 1.36. Okay, and then we are at 1.54. And then at 15, we are at 1.67. All right, let's plot this. We go up and then down and then up. All right. So why does our average variable cost look like this? Why is ours going up and then down and then up again? Okay, well, the average variable cost is the per unit cost of your workers. And so it really depends on how much your workers are producing. So let's go back to our average product. So our average product, it went down, and then it went up, and then it went down, right? Down, up, down, okay, and then it went down. So when we look at the amount that we are producing for the typical worker was decreasing the amount they could make. So if the typical worker is making less, then the $5 we have to pay for that worker is getting spread across less units. So if the average product is going down, what would be happening to the average variable cost? Each worker is making less. They still cost $5. So the $5 cost gets spread across less units. So the average variable cost should be going up. So when average product goes down, average variable cost goes up. When the average product goes up, when we're getting more from the typical worker, the $5 it costs for that typical worker gets spread across more units. So that means that the cost per unit is going to go down. So notice that we're moving in the opposite direction as average product. When average product goes up, the per unit cost of the workers goes down. Here we see our average product is falling. Okay, when our average product falls, we're getting less from the typical worker. We still have to pay them $5, so we can't spread that $5 across as many units. So that means the per unit cost will go up. So if we go back to our graph here, what do we notice? Our average variable cost goes up and then down and then up again. So notice it's the opposite of the average product. So how able we are to spread the cost of the workers across the number of units depends on how much we can get out of the workers, how productive they are. Okay. Now let's look at average total cost. So average total cost comes from taking total cost divided by total product, or by adding average variable cost plus average fixed cost. These actually give you the exact same number because we know that average variable cost is just total cost divided by output, and average fixed cost is total fixed cost divided by output. So it doesn't really matter if you want to add average variable cost plus average fixed cost, or if you want to take total cost divided by total product. Whichever is easier math. Okay, so let's go back here and let's look at our average total cost. So to get average total cost, we can take total cost divided by total product, or average fixed cost plus average variable cost. All right, total cost here is 10 divided by total product of 0. Remember, we're dividing by 0, so that's undefined. We skip that one. All right, so then we have a total cost of 15 divided by a total product of 6. So we get 2.5. Notice that if we add 1.67, plus our 0.83. Ugh, if you do that right. Let's try that again. 1.67 plus 0.83. Right, we're getting that same number, just some rounding error. All right, so if we have a total cost of 20, so we're taking 20 here, and we're dividing it by our total product of 7, so 20 divided by 7, we get 2.86. Then we're taking our total cost of 25 and dividing it by 11, and we get 2.27. Then we take our total cost of 30 divided by 13. We get 2.3. And here we get our total cost of 35 divided by 15. 2.33. All right, let's plot that information. So on that same graph we were using before, we are going to plot 2.55 and 2.86. Okay. And 2.55, 2.86, 2.55, 2.86. Okay, and then 2.27, 2.27, and 2.33, so it goes up a little bit here. That's 13, and then, okay, average total cost. Okay. So let's look at why our graphs have that shape. So notice at the lower numbers of widgets, average fixed cost is going down. Okay. In our example here, we have average variable costs going up. But remember, average total cost is average variable plus average fixed. So as the average fixed is falling, that would pull the average total cost down. But if we have average variable costs going up, that's why we're getting this uptick here. Okay, then average fixed costs get smaller and smaller and smaller. So it's really being removed from the picture here. It's real small. And so what do you notice in terms of the shape of average total cost? Notice it's starting to look a lot like average variable cost in its movements, right? It's going down, it's going up. It's tracking that average variable cost. It looks more and more like average variable cost at the much higher quantities when average fixed cost gets very tiny. Here, where average fixed cost is not as small, then it is going to be influenced by that average fixed cost. If we were to look at the theoretical graphs, what we see is average fixed cost is continually declining. Okay. What we see for average variable cost is average variable cost looks like a U. And average total cost declines and then increases, so it is also a U. Because at the lower quantities, the average fixed cost is pulling it down, the average variable cost is pulling it down, so we get a decreasing average total cost. Then average fixed cost gets really tiny and average variable cost takes over, so it pulls up the average total cost. So average total cost is being influenced by what's happening with fixed and variable. If variable and fixed are going down, average total cost is going down. If average variable cost is going up and average fixed cost is super tiny, it doesn't matter that average fixed cost continues to decline because it's a very small number. That average variable cost takes over. So the theoretical graphs for average variable cost is a U shape, decreases then increases. And that's because, let's go back to our graph here, the average product of labor has this upside down U shape. Now in ours, we saw some extra waves, right? So our average product of labor went down, then up, then down, instead of just up and then down. Because in the production process, when we start changing how many people are folding and how many people are stapling, and we start rearranging the jobs, that is going to change the marginal, this extra being produced, which will influence the average. So the theoretical graphs look like this: marginal product, average product. And so that's going to make our average variable cost have that U shape, because as we said, when you get more per worker, then you can spread that $5 across more units. When you're getting less per worker, you can't spread it across as far. So in theoretical terms, your average fixed cost continually declining, average variable cost to U, that's going to make average total cost to U as well. In real life, things aren't as pretty and clear, and that's because we may change in the middle of our production who's doing what and how we're delegating the tasks. And so we may see a change in that marginal productivity and that marginal cost, which will then impact the average variable cost and therefore impact average total cost. So we want to make a decision then as to how much we are willing and able to produce. And that is going to depend on these cost curves. But we need one more really important cost curve, and that is the marginal cost curve, the extra cost to make one more unit. So we'll look at that in the next video.